Okay, this is our second lesson for Chapter 7. We're going to use the Pythagorean theorem that you dealt with in Section 7.1, but we'll be doing the converse. And remember from our other chapters that the converse means we are just flipping the two ideas. So in 7.1, we said if you can do the two sides, they will equal the hypotenuse. In this case, we are going to say if I have all three sides and I solve it out and the a squared plus b squared equals c squared works, it will then be a right triangle. So we're starting with all of the sides in this case. So if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So let's fill in right triangle. And again, here it is written in just letter format. If c squared is equal to a squared plus b squared, then ABC is a right triangle. So please do not forget, though, if you're dealing with three numbers, the largest has to be the hypotenuse. So that's kind of key. The biggest number that you have always has to be the c squared or the hypotenuse. So we're going to tell whether the given triangle is a right triangle. So in this case we have a 6, a 9, and a 3 square roots of 13. Now, we don't know how large 3 times the square root of 13 is to know if it's the largest side. So we could solve that out on our calculator. We could say 3 times the square root of 13. That actually comes out to 10.8, so we know that that side is the c side or possibly the hypotenuse. So we are going to take the a, the b, and the c and see if it works out. So 6 squared plus 9 squared, and we're comparing it to 3 square roots of 13 squared. So if you do this on your calculator, 6 squared plus 9 squared is 117. If you do this on your calculator, 3 times the square root of 13 and then square that, that too is 117. So this triangle A is a right triangle because the a squared plus the b squared equals the c squared. Now if we look at the second one, again we have three numbers, 16, 24, and 29. This has to be the c because it's the largest number, and these two are the a's and the b's. That order does not matter. So we're going to say 16 squared plus 24 squared and compare it to 29 squared. Again, 16 squared plus 24 squared is easy to do on your calculator. That equals 832. 29 squared is 841. And again, since those do not match, this is not a right triangle. Okay, we'll do it again 2 more times. So again, we have to decide which is our largest side. So if you do 2 times the square root of 10 on your calculator, it's 6.32. So that will be our c, and again our a and our b. So 5 squared and 4 squared, we're going to compare to 2 square roots of 10 squared. So 5 squared and 4 squared is 41. 2 times the square root of 10 squared is 40. So this would be not a right triangle. Okay, lastly, we have 3 times the square root of 61 and 18 and 15. Again, we've solved this out to know if it is the largest side. So if 3 times the square root of 61, 23.4, we're going to use that for our c, so this will be our c, and again a and b's do not matter. So 18 squared plus 15 squared, we're comparing to square root of 3 times 61 squared. Now 18 squared and 15 squared is 549. 3 times the square root of 61 is also 549. So this is a yes, it is a right triangle. Okay, at the end of the video I'm going to show you how to square this 3 times the square root of 61, because if you make it into the decimal, it'll be a little different, but I'll come back to that because I don't have any space on this paper. I'd like you to look down at the methods for classifying a triangle. What you are really going to be doing is comparing c squared, which is the longest side, to the addition of the other two sides. So again, we've already done this one. If c squared is equal to a squared plus b squared, then angle C is a right triangle, and we've dealt with that already. Okay, now, if c squared alone is less than a squared plus b squared added together, then angle C is smaller than a 90-degree angle, and ABC is an acute triangle. So if c squared alone is less than, we have an acute triangle, and of course on the other end of the spectrum, if c squared is larger than the a squared and the b squared added together, then c is bigger than 90 and the triangle becomes obtuse and greater than. So on the reverse side of this, we are going to work out if we have the triangles and if they are rights, acute, or obtuses. So if you flip your paper over, and I know mine doesn't always focus immediately, but it does come into focus, plus you do have the paper in front of you to read, so you will be able to read my handwriting. Okay, if you look at this, it says, can segments with lengths of 2.8 feet, 3.2 feet, and 4.2 feet form a triangle? So we have to answer that question first, and then we answer the question of, if so, would it be acute, right, or obtuse? Now, remember, to decide if it's a triangle, two sides added together always have to be larger than the third side. So here's my three sides, 2.8, 3.2, 4.2. So 2.8. The other two sides, 3.2 and 4.2, have to be larger. From the 3.2 side, 2.8 and 4.2 have to be larger, and on the 4.2 side, 2.8 and 3.2 have to be larger. So if we add 3.2 and 4.2, is definitely bigger than 2.8. If we add 2.8 and 4.2, it's definitely bigger than 3.2. And if we add 2.8 and 3.2, it's definitely bigger than 4.2. So yes, it can form a triangle. So that's the first step you have to do. You have to decide if you actually have a triangle. Then from there, you're deciding, is it an acute, a right, or obtuse triangle? So in this case, we have three numbers, 2.8, 3.2, and 4.2. Okay, we immediately know that this is going to be the C because it's the largest number, and then these two, we can label A or B, and it doesn't matter. Now, the easiest way to do this is to put the C squared on the left side, because then it matches the symbols or the greater than or equal to or less than that you put on the other side of the paper. So I'm going to put 4.2 squared here, and then I'm going to say 2.8 squared plus 3.2 squared there. So I've now done C squared, A squared, and B squared. Okay, if we square 4.2, it becomes 17.64. If we do this on our calculator, 2.8 squared plus 3.2 squared is 18.08. Okay, we put in the correct symbol. 17 is less than 18. So if you look at the chart on your front page, it says if C squared is less than the two other sides combined and squared, we have an acute triangle. So C squared was less than A squared plus B squared. So this triangle is acute. Okay, then, can segments with lengths of 6.1, 9.4, and 11.3 inches form a triangle? And if so, would it be acute, right, or obtuse? We have to do the same thing as before. So we have three sides of the triangle, 11.3, 9.4, 6.1. So the 11.3, we have to add up the 6.1 plus the 9.4. the 9.4, we have to add the 6.1 plus the 11.3, and the 6.1 side, we have to add the 9.4 plus the 11.3. So 6.1 and 9.4 is definitely bigger than 11.3. 6.1 plus 11.3 is definitely bigger than 9.4, and 9.4 plus 11.3 is definitely bigger. Remember, it is only a triangle if all three of these are greater than. Okay, so yes, it can form a triangle. Now remember, if any of these had come out to be less than or equal to, you'd stop here because you do not have a triangle. Okay, then we're going to take our A, B, and C again. So we have 6.1, 9.4, and 11.3. And again, A and B don't matter, and C is the one that we're concerned with. So we're going to say 11.3 squared, and we're going to compare it to 9.4 squared and 6.1 squared. I know I just put them out of order, but A and B don't matter. So we have C squared, and then A squared plus B squared. So we do this on our calculator, we get 125.57. 11.3 squared, we get 127.69. If you look at my numbers, 127 is greater than 125, so C squared is bigger than, let's see, we said the 9.4, so actually B squared plus A squared. Now that order doesn't matter, you just have to add the two of them up. So in this case, we have an obtuse triangle. So don't forget, when you're deciding if it's an acute, right, or an obtuse, if the C squared alone is less than the A squared plus the B squared, it's an acute. If the C squared is greater than the A squared plus the B squared, it's an obtuse. And if the C squared is equal to the A squared plus the B squared, it is a right triangle. Now, I'm just going to go over something that was on the front side to remind you. So, for instance, if you are multiplying 3 times the square root of 13 squared, please do not do 3 times the square root of 13 and get a decimal and square it. That will not work. Okay, because you have to do it as, remember, you distribute that 2. This really becomes 3 squared times square root of 13 squared. So it actually becomes 3 times 3, 9, square root of 13 times square root of 13 is square root of 169. So it really becomes 9 times 13. And 9 times 13 is where we got our 117 on the first page. You must do it in this order, because if you do 3 times the decimal of square root of 13 and square that number, you will not get the 117 that you need. Okay, so don't do it this way. Make sure you go up and realize that 3 times the square root of 13 means 3 squared times square root of 13, which means 9 times 13 are 117. So practice that on the other side. Okay, this is the end of the 7-2 video. So again, you'll have some problems relating to this. And then we should move on after we get through 7-1 and 7-2 to 7-3, which takes us a little bit further into dealing with some right triangles.